Okay. I think you should be able to hear me. Mm. Hello. Can you hear me? Is my audio okay? Okay, cool. Yeah, I know. I could tell. Me pull up this just so that way I can see the chat as we're going.
Okay, sorta accidental.
That's not. Okay. Maybe give like maybe a few minutes, just so that way anybody who's possibly wants to show up has a little bit of time before I jump into the review session, because I don't want anybody to miss anything. How's everyone's day? We doing all right? Oh, I don't know. Oh, cricket like the sport. Okay. I thought you were talking about the insect. I'm like, okay, that's an odd hobby, but all right. Yeah, I'll start up at 3:05 just to be sure. Okay. All right, let me mute this so I don't hear myself double talking. And then, oh, it's only 3:03. Yeah. Okay. I got a really creaky chair, so I'm sorry if you hear that. Okay. Just to confirm one last time, everyone can hear me, right? Volume's good. Not too quiet, not too loud. Hmm. Will I be going over the overall topics? Um, yeah, pretty much. I picked out the what I think is the most important stuff. Um, I added a little bit at the end because I realized that some of the stuff that I picked didn't necessarily go over a few things like the final keyword, the sort of the aspect of Java docs. You guys have like are just now getting into that, but I'm pretty sure it's fair game. Not as far as like coding is concerned, but we could ask you like one question about it. So I definitely want to address it. So all right, great. I wonder if this is. I hope this isn't lagging. It's fine. It'll be all right. Okay. All right. Let's get started. Oh, and just so everyone is aware, this will be um recorded. So it'll be a VOD of it, so you can refer back to it and stuff. And also, I'll probably upload the slides that I use too. Yeah. Oh, because I was trying to study all the topics. Yeah, the VOD will be up later. Because I was trying to study all the topics, had practice problems used. Well, that's kind of the. I guess I would go and pull this up. That's kind of the interesting thing. This will be the last question I answer before I'll just jump into this. Yeah, this is all being recorded. Yeah, this is all being recorded. For as far as like what you should specifically be studying, it's not. I'd say that this is special in the way that a lot of topics are kind of interwoven with each other. So to do well on the exam, it's a good practice to be able to identify multiple different things inside the same question. You'll see that a bit through here. Because I make it so the questions themselves they should be harder than the stuff on the exam. And again, if they're not, then they're like borderline the same thing. None of them are easier. I'll say that. Yeah, let's hop into it. I think everything should look good. Everything looks good. Okay. That was interesting. Okay. All right. Well, hello, everyone. This is going to be the review session. I'm going to move that over here just so that way I can read it. Not there. That's not where I wanted you. Are you doing that? Wow, that is. Wait, can I do that? Oh, dude, that's sick. Oh, that's sick. All right. Sorry. I'm like a kid in a candy shop figuring this stuff out. Okay. All right. Okay. Jump straight into it and I'll stop yapping. Okay, so to start off with, this portion is the review. Yeah, this portion is going to be the review. So I'll just keep. This portion is going to be the review where I'm asking you point blank questions. Less of it is actually, hey, free for all, ask me any questions you got. I'll try to answer those. But most of it is just going to be straight up, hey, here are the things that I think you should be aware of. And that's roughly about it. OBS is like destroying me right now, and I don't know why. There we go. There we go. There we go. There. Okay, love. Okay, sorry about that. Hopefully that was the last of the technical issues. Even though you can't see anything, so it just looks like I'm bumbling around like a moron. Okay, cool. All right, there we go. Lovely. Okay, so the way this is going to work is I'm going to ask you all questions, and I will either poll you or I'll just be like, hey, is this compile? Does this not compile? If it doesn't compile, what's the error here? A few true or false questions, stuff like that. And then whatever I see the most of, I'll take that as just a consensus answer, and then we'll work from there. After each problem, I will have a sort of rule to code by. It's essentially just a rule to help you remember certain things, and that's it. And then I'll have an exhaustive list at the very end. So the way this will work is this will be roughly 60 minutes for this, and then roughly probably not 40 minutes, more like hard to hear. Okay, is it still hard to hear, or is it okay now? Shouldn't be hard to hear. Okay. Can everyone hear me right now? Say like yes or Y or something in the chat, just so that way I know. Here on my side. Okay. Okay. All right then. All right. Just a little quiet. Okay. Well, I can't do much about that because if I do that, I'll just try to talk a little bit louder for you. And I think that should be enough. Okay. All right, I'm just going to jump back to it. Okay. Yes. All right, cool. Okay. So we'll just keep going. Then in part 2, the open Q&A on Twitch, essentially just going to be me and TA buddy of mine, Ron, will be just playing some game. And then as we're playing the game, I'll be looking over at the chat. I'll read them out loud, and then he and I will chime in and answer your questions. I mean, it can be anything. So yeah, let's get to it. All right, so the way this is going to work, or I have these really cringe names. I don't know. I just made them up. Each different section is going to have sort of rules to code by at the end of them. Each section should have, I think, 2 questions. I'm pretty sure that's how I did it. But then, so the first one we have is constructor corner, which is going over the keyword of this, the keyword super, static versus instance, shadowing. The second one is aliasing alley, shallow versus deep copy, arrays, pass by value versus mutation, inheritance island, override versus overload, dynamic dispatch, and visibility rules. Then we have object observatory, which is toString equals / hash code, the sort of pitfalls that go there. More so talking about their contracts, especially when it comes to hash code. And then sort of wrapper gotchas with wrapper classes, because I know people have issues with that sometimes. So yeah, let's keep moving. All right. So the first thing, constructor corner, what specifically you're going to be talking about, constructor chaining. So this is this keyword funnels into the most specific constructor. So that goes by whatever the arguments are. So if you have, well, I mean, we'll just keep moving forward. We'll get to a question and you'll see it. So, so it'd be constructor chaining, superclass constructors. So when super, the keyword super with parentheses is required to call a superclass constructor. So that's a constructor that's in the parent class of the class that you are in. Static versus instance fields. Who owns that data? Is it an instance? Is it the class itself? Is it shared? That kind of stuff. Shadowing is the idea of you have some variable equal to itself versus this dot the variable name equal to the variable. What's the difference there? And what are the implications of using either of them? Okay, so first one. This is just a simple, will this compile or will it not? So I'll just read it out to you first, and then I'll give you maybe like a minute or two to go over it yourself. First thing is we have class A. Class A has a constructor public A with one parameter of int x that prints out A plus whatever x is plus a space. Then we have class B, which extends A, and that has a constructor that is a no-arg constructor, and it has a constructor that has one parameter, which is an int. Then we have public class test, and now we are actually calling on the constructor inside of B that has an int for its parameter. So tell me, does this compile? And if it doesn't, or actually, we'll just go to the first one first. So tell me, does this compile? Yes or no? Yes, yes, yes. Oh, no, that's from before. But tell me if it compiles. Okay, so one person says yes, it does. Anybody else want to chime in their opinion? Yes. Okay. 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 I'll go ahead and yeah, I'll give you guys like it's hard to say because I think the voice is delayed a bit. But it yeah, the voice is delayed a little bit, but we'll fix that for next one if we do another one. I'll give you like a minute or two, so in reality it's like 3 minutes after I say it, just to make sure you guys hear it and you do it. So the answer here for does it compile, it's actually no. No, it does not compile. And the reason for this is, well, actually, yeah, no, I'll just say what it is. The reason that it doesn't compile is because if you notice, if we work from the public class test, first thing we do is we say, okay, new class B, we're calling on the constructor that has an int in it, right? So then we do that. And we go into, oh, wait. Oh, wait, hold on, sorry. Oh, yes, sorry, my bad. If it does this parentheses here, what's going to happen is it's going to then jump into public B parentheses, so that constructor. If you notice, there's no direct call to the superclass, right? However, it's implicitly there. So the way you can kind of read this is public B in parentheses, and then you look up, if it's a class that's a child, you look up to the parent class. And then what you do is you say, okay, I need the class that is the most, or the constructor that's the most broad. So the most broad constructor there is going to be the one that takes in no parameters, because that's the one that we always have, right? For public B, you do not have it's an implicit call for super parentheses there to the super constructor. And when it implicitly calls the superconstructor of A, it calls the superconstructor of A that has no parentheses in it, because you are not explicitly calling the parent constructor A with the int in it. Because remember, whenever you go ahead and give a constructor that is not the no-args constructor, the no-args constructor goes away, right? It's no longer there. If anything, you can think of it as it's a courtesy. Java leaves it there for you as a courtesy when you don't give it any kind of constructor. I could go into like why exactly that is in the back end, but that's kind of unimportant. If a public B within X was before, no. No, because that's kind of Python logic. It remember for Java, it doesn't really matter where things go when you're writing it inside of a class. Because a lot of it just points to different things, right? So if you call, let's say we do switch them. If we switch them and we say public B and X, and then blah blah blah, and we say this call, and then we say public B, right? The no args constructor for public B. It's still that this call goes to public B first, right? The no args for B. And then once it's there is an implicit call to its superclass. There has to be. For all of them, for all classes, there is an implicit call for it. Even in classes that don't directly extend something, there is an implicit call to super, but that call to super is the call to the object class, right? Because all classes extend the object class. If it's not extending it directly, then it extends it indirectly. Isn't B3 calling the... Yes, it is. So it does this before calling super. So when you... Okay, so this parentheses and super parentheses, they are... You can only have one inside of a constructor. So for instance, this... Oh, where's my mouse? Oh. So for instance, I hope the voice lines up for this. For instance, this here, right? When we do public B, one arg param for the constructor, and then we do this parentheses, this is a direct call to public B no args, right? But if I did here super with no arguments in it, it wouldn't go here. It would attempt to go into class A and access some constructor in there that has no arguments. You can't write this and super. And you can kind of think of it as it doesn't make sense for you to base some idea of what you are twice. When you call this parentheses, you're essentially saying, hey, go here and assign the information, give me whatever the information that I need to define what I am first, and then I'm going to do the rest of it. Super does the same thing. It's just super goes to a parent class. If you don't put super, if you don't put this, there is an implicit super every single time. So if you didn't put this in the one argument constructor, it would implicitly call super. Both of them would. Now it's just the no arg in B that calls super to A. Does that make sense? This is one of those questions that this is definitely, I think, harder than we would ask you on an exam, but it tests your ability to understand really what happens when you do this and don't do that. This kind of makes sense? I think a good way to think about it is... So this implicitly calls the no arg constructor in class A, but there isn't one. No. So this parentheses, and whenever you see this, when you see the keyword this, it's always within that class. It never jumps outside of that class. Think about it as you're saying this. This is a lot of this, but this is this. You can't refer to that, if that makes sense. If you are saying this inside of a class, we're referring to something within that class. We're referring to, if you have this with parentheses, we're referring to a constructor that is within that class. The reason that we're going to the A constructor that has no parameters in it is because of the this call inside of B that then chains to the no arg constructor in B. But inside of the no arg constructor in B, there is an implicit call to super. There has to be. There's no way around that. You either have it implicit or explicit. So the implicit call then jumps or attempts to jump to public A with no parameters in it, right? The no arg constructor. But you don't have that anymore because you already defined a constructor inside of A that's not the no arg constructor. So there would be a compile error. So without a this, the super gets added. Yes. Yep. There is, if you do not put this, there is a super, 100%. And it is the first line in your constructor every single time. So, so it is not compiling because class A does not have the yes, correct, because it does not have the no arg constructor, 100%. That is why in this case it is not compiling. There's a few ways you can go about fixing this, but a good way of thinking about it is a superclass constructor call for, or superclass constructor call, so super, right? The super call, however many parameters are in it, no arg or, 16 parameters, however many, right? That must happen in a subclass constructor, explicitly or implicitly. It happens. There's no way around that, right? So when you see a question like this, you should always look first to see if there is an explicit call for this inside of the constructor. If it's not, that tells you there's a super call. If you look at a constructor like the no arg constructor, and you notice that there's no this call or super call explicitly stated, you know for a fact it's going to jump to the superclass's no arg constructor. And if it doesn't have it, that's a compile error, 100% every single time. So yeah. Beyond this, okay, so I guess one way to fix it, it's probably important. I feel like we might ask you that. Could someone give me a way of fixing this? From the jump, I see 3 ways of fixing this. And if you don't see a way, that's perfectly okay as well. This jumps to the no arg constructor of class B. Yes. This parentheses inside of this call with no arguments in it in the B constructor that has 1 argument in it, that jumps to the B constructor with no arguments. Yes. Change this to super. Changing this to super would not work. Changing this to super would be the same issue pretty much. It's just now you're not jumping to the no arg B constructor first. Instead, you're just attempting to jump straight to the A class with the no argument A constructor, and we don't have one of those. Adding no arg constructor to A, yeah, that works. Adding a no argument constructor to A that doesn't really do anything is fine. There's probably a better way of doing this, I think, but yeah, that works. That does work. This. Oh, I see. I see what you. Well, I see what you're going for there. I think. The person who put. Oh yeah. Well, someone else just said it. Define this inside class B. Define this. I'm not too sure what you mean by that. Focus on the idea of chaining. That's kind of what's important here, more than anything else. The person who put int constructor in A again, yes, 100%. Add super X in no arg constructor of B. Yep, 100%. That works as well. Doing that means it's a direct super call to that constructor of A, and that works perfectly fine. Put super some integer in public. Yep. Replace the contents of B. Replace the contents of B to super int X. Well, you wouldn't want to replace the contents of it. I think what you're trying to say is just put super int X as the first line. I think that's what you're trying to say there. And that would be right. Okay. Any other questions beyond this? If not, we can move to the next one. Move my monitor over so I don't have to turn my head as much away from the microphone. Okay. Super int x in B would then directly call the constructor A. Yep. Yep. That is correct. I'm going to go ahead and move on. I don't see any extra questions coming through, so I'll move back, or I'll address them if they pop up. Okay. All right, next. So, all right. So this is a just predict what's going on. This is a usage of the static keyword and the this keyword. I meant to remove that comment there, but that's fine. Okay, so predict both lines of output for me. So those lines of output are system.out.println A and system.out.println B. And I'll give you a few minutes to do that. By the way, let me know if you want me to change up the approach as well, and just walk through the questions, because I can do that as well. But I think it's probably best if you guys think through it a bit first. But just let me know in the chat if you want me to do that instead. Did I walk through the questions as well? Yeah, 100%. All right. Okay, so all right. Let's go through it. I see a few answers rolling through. Um, huh. I see a few answers rolling through. I think there seems to be a bit of a Wi-Fi problem going on right now. Sorry about that. I wonder if I can. Shouldn't be buffering like. Yeah, the recording should be fine. The recording should be plenty okay. I don't know why it's buffering that badly though. It shouldn't be doing that. Okay, I'm just gonna go through this, and hopefully you guys can hear it, or at least it'll be on the recording as well, and hopefully the connectivity clears up a bit. But okay. All right. So 3-3 for A, 3-2 for B is pretty much the consensus I'm seeing. One person said 3-3 for 3-3 for A, 3-3 for B. And then would be 9-2, or does the internal definition overrule it? Okay. All right. Let's walk through this. So the best way to approach these questions is to just go from public class test or wherever your main method is and work from there. So we have CA, so an instance of C, and we're saying new C. We're calling the no argument constructor. So when we call the no argument constructor, we immediately jump and we see, okay, there's a this call for 7. So then we jump to the constructor that has an int of x, and we have 7. So now we say, okay, x is equal to x, right? So s also becomes 2 as well. We notice that s is static. So s becomes 2, and then x is just and then this dot x plus plus happens. Doesn't string. One second. Let me get through the rest of this, and then I'll address that. Then this dot x plus plus happens. So let me just do that one more time. This call for 7 jumps to the C constructor that has an int as the parameter, jumps in there, says, okay, x equals x, right? And if you notice, there's no this dot x, right? So what happens there is we're saying x is equal to x. All we're saying there is take the parameter that I just got and set it equal to itself. That's what's happening there. So basically nothing. Then we increment s. So now s becomes 2, right? Now we go back because we're done with that constructor. And we say this dot x plus plus, right? Now, interestingly, this dot x plus plus, you could put x plus plus there, and that works just the same. That there's no issue there. But okay, so this dot x plus plus makes a dot x go from 2 to 3, right? And that's it. That's the end of that chain. So then we have C or B, which is of type C. We say equals new C C9. So we go to the constructor that takes in an int of 9. And again, there's no this keyword. So essentially all that's saying is x equals 9, which is already 9, but it's x at the local level, right? So it's not at the class level. And then we increment s, right? So now s is equal to 3, but b.x stays at the default value of 2. So then we immediately go to system.out.println A, system.out.println B, and notice that we've defined a toString for class C. So we know what's going to print out there. It will return S, whatever S is, and then the colon plus X, right? Notice or remember that for A, A's X did update by 1 because of that increment, right? And the S is static. So the S has been updated twice. It's been incremented twice, right? So what's going to print out for A is first S, which we know is 3 because it's static and it was incremented twice. And then it's going to print out X. Well, X was incremented. So X is 3. So it would be 3, 3. And then there's a new line character, I guess. Yeah. And then it'd go down and it'd say, okay, now we're going to print out B. What's B? Well, B S was updated. However, there was no this keyword. So X was never updated. X was never changed the class level for that, right? And because that is an instance variable and it's not static, that means that it belongs to that instance, right? So then what would print out there is S equal to 3. So it would just be 3 colon 2. So the answer would be 3 colon 3, 3 colon 3, and then 3 colon 2. Would be the answer. What did it say? Oh, they'll say, who said, someone said something about, would be 9.2. Yeah. So 9.2, I think the reason that you got 9.2, I think the reason you got 9.2 is because you're getting two things mixed up. One thing is that, remember, it's S then X, so it would be swapped even if X was 9. But the reason that it's not 9 is because of shadowing. When you don't see a this dot whatever and the parameter is the parameter name is the same as whatever it is at the class level, then there's a risk of shadowing. Not to say you shouldn't do that, because I mean, it's just honestly, I think it's best practice to have the same name. It's just to be aware that if you don't put this dot for it, you're not referring to the class level. You're referring permanently to the local level. By the way, does 2, 3, and 3, 2, why is S equal 3 for line 1? So it is and sorry, no. Did I say 2, 3? No, my bad. That was wrong. It was 3, 3, 3, 2. Yeah, my mistake. It'd be 3, 3, 3, 2. Because S is updated for A, at A, it's updated +1, and then at B, it's updated another +1. So then now the value is 3, and because it's static, it's shared for all instances of C as a class. So then it would be 3. So my mistake. That'd be right. Both classes, because it's static, show it shares across all the objects. Yes. Yep. That is why. S is static. That's why. Yeah. I think that's about it for that question. Unfortunately, since it's lagging a bit, I'm just going to go ahead and move forward. Keep asking questions as well if you want, or please do, because I will answer them, even if it is lagged, which, sorry about that. I tried disconnecting a bunch of stuff from the Wi-Fi, but I have AT&T Air. It's booty cheeks. So the reason why X did not change is because it did not go to the C constructor, and yes, doesn't have it. Yes, correct. what? Unix suite? Yeah, Unix suite. I'm probably saying that wrong. Yes, that is correct. For system.out.print. Yes. Yep. 100%. Okay. Let me move forward. Okay. Okay. So now that those are done, those questions are done, those two questions are done, I leave you with a few rules to code by, or rules to sort of remember for the exam. If the parent class has no arg constructor, has a no arg constructor, right? The child must call super args. It has to. If it doesn't, it's going to have a compile error. So what that means is, so for the example of A and B, right? For class A, class B, B extends A, right? So B is a child of A. If class A has some constructor defined inside of it that does not have no parameters in it, and then it also does not then define that constructor later on, it has no constructor that has no args in it. It just doesn't have that anymore. Because basically Java thinks, yeah, no, they're chilling. They handled it already. So I don't have to use an implicit constructor there. So then within that child class, if you do not call super and then matching the arg list for that no arg constructor, you will get a compile error every single time. This calls another constructor in the same class, right? I know someone was mentioning that earlier, but yeah, this calls another constructor in the same class. It never goes outside of that class, period. And it must be the first line. You cannot have it as any other line than the first line. If you put it as any other line than the first line, there will be a compile error. It won't work. Static fields belong to the class, so there's one shared copy amongst all the instances. An instance field belongs to each individual object, each individual instance. The shadowing trap, or the idea, we have x equals x changes only the parameter itself, right? So we saw that for C, right, for the C class, where it was x equals x, and the parameter list had int x in it. So as far as Java is concerned, we're going to go like as not far up in priority as we can, or as in scope as we can, right? So we're just going to go and look up into the class and say, okay, I'm looking for x. Oh, it's right there in my parameter list for this method. I'm just going to grab that, and it's done, right? If you put this dot x, on the other hand, it's like, hold up, I'm going to go and grab the x that is being referenced by this instance, not the parameter list. So yeah, use this dot x. Don't use x. So x equals x is basically do nothing. So it will not update x to any new value, except for yes, correct. All it's doing there is essentially just, I forget what the number was, I think it was 7. It's just saying, like, whatever that value is, equal it to itself. That's it. It's a nothing burger. It does nothing. Okay, cool. All right, moving forward. So, my next cheesy name, aliasing Ali. So the focus here is that we're going to talk about the shallow versus deep copy arrays. So aliasing through assignment and pass by value, reassigning a parameter versus mutating the object itself. Okay. All right. So for the first one, we're going to be talking about shallow copy and what that means, what that entails. Predict what this prints out. So if you notice the system.out.println in the test class, tell me what prints out there. Tell me what prints out there. Or you know what, I might just walk through it since it's lagging. as bad as it is. And then you guys can ask questions about it. Yeah, we'll do that. We'll do that. I think that works better. Okay, so let's just go through it. If we start off, we say person P1 equals new person, new book, A, right? So let's go up and do that. So person P1, new person, and the constructor has a book object in it. Okay, go there. Cool. So book B, there we say book equals B. Notice it's lowercase book, so that's referring to that person's book specifically. And we're saying that that's equal to a new book that has a title of A. Cool. So then we go to person P2 equals new person P1. So we're passing in a person object, right? So then we pass in the person. Notice that the person, the actual data fields that they have is just a book. That's it. So they say this dot book equals other dot book, right? So what's important to note there is when you use equal in reference to a reference type, you are essentially changing where it's pointing, not the contents. So this dot book, when we're saying that, this is in reference to P2. P2's book, person 2's book is pointing, that reference is pointing to the same book object as person 1's book. So they both currently have the same book, right? They're pointing to the same book, right? They're referencing the same book. Yeah. So P2 dot get book, so grab that book reference, grabs it, says set the title to B, right? Then it says system.out.println P1 plus, and then just split it. Okay, so what's important to note there is P2.getBook.set title B. Remember, we just said that P1 and P2 share the same reference. Well, .getBook simply grabs that reference. So currently, P1 and P2 are pointing to that same book. So when we do set title on it, we're going to jump to that book object. And there's only one. And we're going to say, hey, set the title equal to, what was it? B. Yeah, set the title equal to B, right? And then we print it out. Well, because they share the same reference, same book changes, right? There's no new book that was created, right? I think something, so the answer here is simply just, what was the two-string for person? Oh, just the title. Okay. So the print out here is just going to be B/B. That's it. That would be the answer. The copy constructor here, which is the person, other, that thing. The copy constructor copies the book reference. So P1 and P2 simply share the same book object. We're just pointing to the same thing. That's it. If you wanted to make it so this did not do this, so let's say you wanted P2 to have a book that is named B and P1 to have a book that's named A. If you wanted that, then you would simply deep copy the book. What that would look like is instead of this dot book equals other dot book, you would do this dot book equals new book parentheses other dot book dot get title, right? Or implement some book copy constructor and call it, right? So essentially you'd have to deep copy it by copying over the information into a new reference, if that makes sense. And then that's what you're pointing at now. Yeah, I think that's pretty much it. Let's see if anyone has any questions over that. So if you want sort of independence in a way, you would allocate a new internal object when copying. That's what deep copying is, right? It's just allocating space for a new object, a completely new object, not a new reference, a new object. See if there's anything else here that I'm forgetting. Yeah, I think that's pretty much it. This is one of those questions I'd say that this is like definitely fair game for showing up on the exam. Actually, I'd be surprised if something like this didn't show up. Go ahead and ask your questions. Like if you have a question, just ask it, and then I'll answer it when I am able to see it. Yeah, I'm just gonna go ahead and move on for it, and then I'll answer the questions as I see them. Okay, so question 4 is pass by value versus mutation. So, and this is specifically to do with arrays, right? What does this print? Oh wait, hold on. I just see a bunch of stuff come in, so I don't want to skip yet. Explain the difference between aliasing and a shadow copy. Yeah, they're essentially the same thing. Yeah. Think of it as aliasing is literally what the word alias means, right? It's just another word for the same thing. A shallow copy is a bit more involved, I would say, just like rationality wise, but it's basically the same thing. When you think shallow, think literally you're not going into the box that you're referencing, right? So for example, the book, it's a shallow copy because you're pointing at the book, you're not opening it, or you're not reading the title of it. You're not doing any of that. You're just saying, yeah, that book over there, right? A deep copy would say, okay, tell me the title. And then maybe if we made it a bit more interesting, we say the number of pages. Say, okay, tell me the number of pages. Or the author, or however. That would be a deep copy if you then went over and said, okay, I'm going to copy over all of this information that's inside of it, right? That's a deep copy. If you don't do that, you're aliasing. Yeah. For the written code question, what should we focus more on? I can't answer that. That's too much to give you guys, unfortunately. If you understand this stuff, and if you can understand this stuff and you can do the homeworks without looking at your notes, I think you'll be fine. I can say that. But I can't expound on that any more than that, because then that'd be giving you too much. Okay. So for this one, pass by value versus mutation, what does this print? Which lines affect the caller? And which don't, and then state the rule in one sentence. I think that was a note for me, but it's fine. Okay, so let's walk through this. So we have our main method here. We say int array x equals 5, 6, 7, right? And then we say f of x. Cool. So we're passing in that array, or the reference to that array. And then we say, okay, A0 equals 99, right? Then we say A equals new int, new one is a new array, 1, 2, 3, right? And then we say A1 equals 77. And then we say system.out.println arrays.toString. All that is, by the way, in case some of you haven't used the import for arrays, which I don't think any of you really should have at this point. This is just a simple way of doing the toString. That's all. But what prints out there? Well, what prints out there is, if we go back and we say, okay, remember Java's pass by value. right? So the value that we're passing in here is the reference, right? So we're pointing at that same box that contains the numbers 5, 6, and 7. So then when we change the first number in that the first number in that array by grabbing the index at 0, or grabbing the element at index 0, we change that to 99. But then now that we've done a equals new int, we're not pointing to the same thing anymore, right? We're not referencing the same thing. We're referencing a brand new array. So a at index 1 equals 77 is no longer pointing to the same reference as the x int array. So what would print out there is simply 99, 6, 7. I think there would be brackets on it, I'm pretty sure, for that method, but the numbers would be 99, 6, and 7. Yes, yep. It'd be 99, 6, and 7. Yep. Line 4. Yeah. Yes, line 4 would affect the caller. What you can say there is that it mutates the original array. And all that means is like it is directly changing it, right? It's morphing it into something new. Line 5 does not affect the caller because it reassigns the local parameter only. Line 6 mutates the new local array, but it does not mutate the caller array because the references are different now. So important thing to take away here is Java passes arguments by value. Mutation through the reference is visible. Parameter reassignment is not. So when I reassign something inside of that method, I am no longer referencing that same thing. I think that is also definitely something that you should pay attention to and is 100% fair game. The sequence matters. I'm not sure what you mean by that. I'm assuming that what you mean by that is that the order of the numbers matters, which, yes. Or if you're saying the sequence of events, like, oh yeah, that's probably more so what you're saying. You say A0, like if you put A equals new int array before the call for the value at index 0 and the call for the value at index 1, then what would actually print out is just 5, 6, 7. Because now you're not referencing the same thing. Hopefully that's what you meant. Why doesn't the 77 do anything? It's not that it doesn't do anything. It's just you don't see it, right? So if I asked you an additional question, and I think this is a good question as well. If I asked you, what is A, the value of A, at the end of that method? So once we're outside of that method, what is the value of A? Your answer should be nothing. It's nothing. It has been garbage collected because nothing is referencing it anymore. Or rather, the array that is inside or is being referenced by A has been garbage collected, right? So the 77 did change, or the 1 did change to a 77 for that new A, but then we're not using it, we're not returning it, we're not doing anything with it, right? So it's just garbage collected and it's gone. Where's the donation link? There ain't one. I would say when arrays have the same reference. Wait, I would say when arrays have the same reference, if you modify one, you modify the other. Yeah. I mean, it's the same thing with any kind of reference type, right? If you are referencing the same thing, meaning you're pointing to the same thing, it is the idea of you like two different people pointing at the same box and saying, hey, whatever's inside that box, I want that thing changed. Well, if one person is saying that, just because the other person didn't ask for that thing to be changed, it doesn't change the fact that something did change in that box, right? Because it's the same box. Yeah. It is... Oh. Why doesn't the 77 do anything? It is not in the same memory location anymore as X. Yeah, that's right. Um, I would probably say more so that X and A, there are two different arrays now in memory, but that's probably a bit too much, to be honest. But okay, let's move on. If you have any more questions, obviously just shoot them in there. Okay, so rules to code by for aliasing Ali. That name sucks. Okay, so shallow copy is shared mutable internals, right? That's just the idea, again, of let's say you and another person are both pointing at the same box. That's it. And then you change something, changes for the other person, it has to. Changes leak out. I think what I meant by that was that it leaks into the other instance. So back to the previous example with person, with the two people, and you had referencing the same book. The changes from P2 leaked into P1 because it was a shallow copy of the book reference. Deep copy breaks the shared references. Yes, exactly. It essentially like spurs off an additional arrow. If you like to think of it as pointing at something, it points at something completely different. Assignment copies the reference, not the object. Yep. It's essentially all that's really saying is just when you are assigning something, that's the using the equal operator. When you're assigning something, you're essentially saying, okay, that is the reference that I'm hosting right now, right? You're not hosting the entire internals of that object. You're just referencing it. That's it. You're just pointing at it. You're not copying the entire box. Mutate through a reference, the caller sees it. So if you're calling to a method and you are attempting to mutate through a reference that is being passed by value into that method, the caller will see that and it updates it accordingly. If you reassign the parameter, the caller does not see it. If we print out toString, I'm going to go ahead and move this to the next one. If we print out toString A at the end, it's going to be no. If you did toString A, if you did toString A inside of F and you did like arrays.toString A, then yes, it would do 7223. If you attempted to do that outside of that method, you'd get a compile error because it doesn't know what A is. A isn't a thing at that point. It's been garbage collected. Okay, inheritance. I'm not saying that. Inheritance. So the focus here is override versus overload. So same signature versus different parameters. Dynamic dispatch applies only after overload resolution. Visibility rules, so the difference between public, protected, default, and private. Static method hiding, not overriding. So yeah, let's get into it. Okay, first question. What prints? Why doesn't dynamic dispatch pick child.f integer? And then when is method choice decided? Yeah. Okay. Yeah, right. I'm just jumping straight into it. Okay. All right, let's just start from class test and the main method. So we have parent P equals new child, right? And class child extends parent. So that's okay. So we immediately jump to the NOR constructor for child, right? Which then inside of there jumps to the parent constructor there, which the parent constructor is also empty. That's fine. But then the important thing to note here is if you do p.f3, the important thing here is to know which f is it going to go to. Is it going to go to child's or is it going to go to parents, right? Well, pretty much what happens here is it's going to say, okay, p.f of 3, well, at this point in time, I am a parent. I'm going to look up to parent, and I'm going to see if I have a method for it. Turns out I do. So now I'm going to grab that string. I'm not going to go to the child method. I'm not going to do that. And then you grab p, and then you print it out. So then the answer would just be p. Child.f integer is an overload, right? Not an override. There's an important distinction there. It is a different parameter type, right? So the difference between overload, override has to do with the parameter list, right? So if you change the parameter list, you are overloading it, right? If you don't change the parameter list and instead you change the implementation, now we're talking about overriding it. So you pick a signature, just to kind of work through this a bit, I think, because I think a decent amount of people get confused. Like, hey, why do you pick parent, right? I mean, it's a child. You just said it's equal to new child. Why wouldn't you go there? A good way to do this is you pick this signature, so the method signature, at compile time. Then you dispatch at runtime only for overrides. So what does that mean? What that means is we are selecting parent.f number. The reason we're selecting that is because at compile time, we are paying attention to what the left side of the assignment says. The left side of the assignment says that we are a parent. Whatever this is, P is a parent. So if you then attempt to call a method on P, that method has to appear in the parent class or the class parent. You see what I'm saying? It has to appear in there. If it doesn't, you have a compile error. 100%. So it looks at parent, says parent.f number, cool, right? It sees that. But notice, child, even though it's the same name, it's not the same signature, right? Child does not override that signature. So instead, parent runs. Now, if you changed integer, the parameter value, integer inside of child's f to number, then it would print out C. The reason for that is because that dynamic dispatch happens for overloaded methods. Overridden. Sorry, for overridden methods, not for overloaded methods. Yeah. See, 2 questions. Wait, new child calls what exactly? New child just, so all that's happening there, right, is we're saying new child is just calling to the no arg child constructor, and we didn't give it any behavior, right? So technically speaking, what's happening there is there's an implicit no args constructor inside of child. The only line of code that's inside of that constructor is just a super call to parent, and then parent also has a no arg constructor that's implicit that then has a super call inside of it that is implicit that calls to its parent, which its parent is object, and then that's where that chain stops. But that's all that's happening there. We're not there's no new behavior going on. What is number in? Don't worry about that. It's just another. It's like you have integer, double, float, like the wrappers, and you have number, which is just more broad than integer, float, and double. That's it. That's all it is. Probably would have been better if I just named it int, but I wanted to use wrappers. But yeah, that's all it is. It's just a broader definition. Instead of it has to be an integer, it has to be a float, it has to be a double, it has to be a long. It's just number. Yeah. I think that's good. If you have any more questions about it, this stuff can be a bit confusing. So if you have any more questions about it, shoot them in the chat. I'll answer them. But yeah, so moving on. We have so the output is C. No, the output is P. The output is P because at compile time we're looking at the left side of the assignment operator for P, the instance P, and that's a parent, right? So when we jump up to parent, we say, hey, do you have this method that I'm attempting to call, which is F? Yes, I do. Okay, you have that method. Awesome. Then at compile time, when this actually runs and when things are being printed out and all that kind of stuff, when this runs, now we're going to check for, I don't know if you guys have heard of static versus dynamic types. I kind of am trying to avoid that. But you check the dynamic type or the right-hand side. And you say, okay, is that going to be a parent? No, it's a child. Okay, so I'm going to first look inside a child and say, hey, do I have a method that matches the method signature of it, right? That includes the parameter. No, I do not, because that method of F, even though everything else matches, the parameter list doesn't, which means it's no longer an override, it's an overload. So it says, okay, can't use that one. So then it jumps back up to parent and says, okay, use that one. So then it prints out P and not C. Hopefully that makes sense. Okay. Which fields are accessible? This is just a base class. And then there's a subclass, and then there's another class that's not a subclass and in a different package. Okay, so I'll just walk through this one a bit. Okay, so we have a public int pub, we have protected int pro, we have just default int def, and then we have private int pry. Okay, so the question here basically is just like, what are the accessibility or the visibilities of each of these? So pub, you can see literally anywhere. In this particular context, it's probably better to think of it as pub can be seen in a subclass. It can be seen in a different package. It can be seen, it can be seen anywhere, basically. Public literally means it is public to every single person, every single thing, right? Can access it. Protected, on the other hand, is now saying, okay, well, not everyone can see it, but I am saying that my children can see this information, right? But if it is in if it's in a different package and it's my child, they can see it 100%. That's okay. If it is in a different subclass, or sorry, a different package, it's in a different package and it's not a subclass of mine, you cannot see it at all, right? Protected is also, you can still see it if it's not a subclass and it's in the same package, that's okay. But if it's in a different package and it is a subclass, it's my child, that's all right. They can see that information too. Now, the two that get mixed up the most are protected and default. Default is slightly different than protected. Default is, now we're not talking about whether, we really don't care if it's a child. We don't care anymore. Now it is purely, hey, am I in the same package as you? Yes or no. If we're in the same package, go for it. If we're in the same package, then you can access the information. If we are not in the same package, you cannot access that information, period. At all. For private int, pry, that's only within that class. Nowhere else. So to kind of, I guess, just run back through that. Public means it's visible everywhere. Protected means it is visible within the same package, or it is visible to all children outside of that package, so in a different package. Default is it is visible within the same package, and that's it. It is not visible outside of that package, period. For private, it is only visible within that same class. And that's it. Why is default not accessible from package 2? Where did I write package 2? Did I just not? I guess I just forgot to write that. I mean, if we're assuming here that why is default not accessible from package 2, I mean, the reason for that is I'm assuming if these classes are inside of the same package, and then you have another class that's in package 2, just by definition of default, it can't access that information. It has to be in the same package. I think this stuff is fairly straightforward, but maybe make a table for yourself and just try to memorize this stuff. Yeah. Okay. So now, static method. All right. So is this true or false that B overrides the G method? If false, what is this called? Which type decides which G method is used? Again, I'll just go ahead and go through it. Okay. So when we do public static void main string array args, we say A, X equals new B, right? We do X dot G parentheses. When we do AX equals new B, this is like same idea as what we were just doing a little while ago, right? We say, okay, at compile time, we say X is of type A. Then at runtime, we say X is of type B. So then when we do new B, we say go into B constructor. None of the constructors have been defined, so nothing happens. Defines it just fine. But then we do X dot G, the call on the method, right? Now, when we do static void G with no args, and then system.out.print A, then we do static void G, system.out.print B, right? Those two have the same method signature, right? However, because it is static, this B overrides G is false. It does not override G. Static methods are not overridden. This is what is called method hiding. Reference type decides the call. So the reference type is of, the reference type is of A, my mistake. The reference type is of A. That decides the call itself. And we're saying that X is type A. So A.G runs and prints A. Think of it this way, because this, I feel like for some of you, this will be very confusing. So just stick with me on this. Overriding is runtime. Static does not do runtime dispatch. Doesn't do it. Try to read it like A.G, like A.G parentheses, so calling G when the variable is type A, right? So it's, I think a good way to think about this is, and something that you might be thinking to yourself is, well, it would have to be B, right? Like B would have to override it because X points to the new B, right? Or not even that it would override it. That's just what's got to print out, right? But that behavior is dynamic dispatch. But the important thing here is that the static keyword breaks that. It does not work anymore. Instead, you can think of it as the same idea as if you have a static method. That method belongs to that class, right? Because if you said a dot whatever that method is, a dot g, right? That works because it's a static method, right? That method having belonged to that class, Java essentially says, hey, we're just going to define these two things as two completely different methods, right? And we're going to use, since it's a static method, we're going to use whatever it's defined at compile time. We're going to use whatever reference type is compiled or is at compile time, which in this case is your static type. That static type is A. Your compile, I don't want to say compile type, but you can kind of think of it that way. The type that is there at compile time is A, right? So when you do x.g, it has to be A. Has to. There is no way possible for you to get B. You just can't. Now, if we switched it and we said bx equals new A, now it's going to be B. However, B still does not override G. That is never true for static methods. Static methods do not follow that dynamic dispatch idea. Hopefully that makes sense. And it's called method hiding. That's what that idea is called. Okay. Let's move forward. Okay, so rules to code by. Again, this is just overload selection happens at compile time, which is based on reference type and argument types. So that's just the parameters that you're talking about. Dynamic dispatch happens at runtime, but only for overridden methods. So again, dynamic dispatch happens only at runtime, but only for overridden methods. And that's important because static methods are hidden. So you can't override that. Protected equals the same package or subclass access, so children can access it. Default is just the same package. That's it. Static methods are hidden. They are not overridden. The reference type decides what the call is. The reference type we're referring to is, the reference type we're referring to is that static type. That static type is A in this case. Remember what I just said too. We switch those two and we say bx equals new A. That reference type at compile time is B. That might sound confusing. Let me clarify. I said bx equals new A. Bx equals new A. At compile time, the static type is B. So it's going to go to class B and grab that method. See. So if class A did not have static, the output is B. If class A did not have static, if class A did not have static, the output would not be B, no. It would not be B. And the reason for that is because the method inside of B is still, method G, still has static on it. So it's still hidden. It's still hidden. So it will not see that. Because the reference type at compile time is the static type, which is A. Period. And then default can be the same class. Yeah, 100%. Okay. Ask more questions if you need as we keep going through this. Okay, so object observatory. So the focus here is now we're talking about toString. What prints when you print an object, and then equals, sort of pitfalls, trickiness to it, how you should write an equals, that kind of stuff. So null / type checks and contract intuition, so that I'm pretty sure you all have talked about the contract in class. I would hope you have at this point. And then we have wrapper classes. So boxing, unboxing, and why equal is dangerous for this. Okay. So name 2 ways this equals implementation can crash or violate the contract. Okay. So, yeah, okay. Sorry. I need a little bit of water. Okay. So, to start off with, we notice that, well, we notice a few things outright, right? So, first thing that I would do if I were you is just make sure like the actual method header is correct, right? And if you put an override tag there, like nothing's gonna break, basically, which is true. Nothing here will break. However, just immediately, I see a problem with this. And the first thing that I see is that there is never a check for null. That is terrible. Don't do that. That is like the very, very first thing you should do every time is to say, hey, is this null? Because if you don't, it will get a no pointer exception when you do a cast or you try to access any of the fields. Yeah, yep, P can be null, 100%. Yep, that's the problem. What is contract intuition? That's literally just your ability to be like, hey, I know the contract for an equals method. That shouldn't be like that. That's it. That's all it is. Or what should go there, kind of thing. The other thing, what happens if O, because we're taking an object, right? If the type is object. What happens if O isn't a point, right? If O isn't a point and we're trying to cast it, that's a class cast exception, right? Not good. That doesn't work. So the risk here is that without type checks, which that's what that is, checking to see what the type is first before you attempt to cast it, you can violate the, hold on, it's on the, symmetry. Sorry, it's been a while since I've looked at it. You can violate the symmetry portion, right? Especially when it comes to subclasses. You'll end up seeing that where, I'm sure you've talked about this, but the difference between using get class and then using instance of, where instance of is a lot more dangerous when it comes to that idea of symmetry, and it violates it pretty often. But the fix here is to first check, right? One thing you could do too is do a sort of identity check. So literally just say like, hey, is this the same thing? If I'm doing equals with myself, obviously it should return true, right? So that should probably be the first thing you do, but it's not necessary. But so you do an identity check to just be like, hey, am I me? And then that's it. And return true if you are. Elsewise, just keep going. Then you do a null check. So do, I don't know, if O equal null, then return false. Done. Then do a check for the type that it is. Right? So if you're saying if O.getClass is equal to this.getClass or getClass, then you're good. We're chilling. If it's not the same thing, return false immediately, right? Because it's not the same class, so why are we bothering at that point, right? We know it's not the same thing. The issue with instance of is that if I were to give you something like animal and dog, right? And I say animal is an instance of dog, that would be wrong. If you said that, or sorry, no, that would be my bad. That would be correct. If I then said that dog is an instance of animal, that would be correct, right? But there's a problem with that. The problem there is now if you attempt to cast it, cast animal into a dog, right? And then call on information that dog has. And this is inside of the dog class, right? For the dog equal method. You're going to have issues because now that you've casted it, there's information inside of dog that animal most likely does not have access to. So you're going to get errors. So use a get class check. Don't use instance of. Instance of is bad. That's a bad way of doing it. Yeah. So then once you do a get class check for it, then you do that casting. If it was true, like if they're the same class, then you can cast O like it is here, and then you compare the fields, right? If the equals is overridden, it is best practice as well to override the hash code function, or sorry, method. I don't know how much Musave and Chambers have talked about it though. So I'm going to go over it a little bit, but nothing huge, because I would highly doubt that you have to code that. The hash code, that is. So hash code pairing, you kind of, it's convention to pair the two. Actually, I won't go too much into it. But it's convention to pair the two of them for a multitude of reasons. But for your purposes, I think I do mention it a little bit later, but it's not that important. So if you try to fix something by changing the signature to equals, like equals and then in parentheses point here, right? To like the name of the class or whatever. That is an overload, right? That's no longer an override. That's not an equals method. Period. Right? So if you did that on an exam, you would be wrong. Just straight up wrong. If you change the method signature, you are now overloading. You are not overriding. It is wrong. Another thing, yeah, I mean, basically essentially the same thing. Just remember that equals takes in an object. That's it. Literally object. It does not take in the name of the class. I've seen people do that a lot before. So don't do it. just don't do it. Okay. So next one. Okay, yeah, this one's fairly important. Okay, so predict all 3 lines. What do they print out? Why do the first 2 lines differ? Probably shouldn't have put that there. What's the safe rule for comparisons? Yeah. Okay, again, so line 1, A equal B. Well, we see that integer A is equal to 128, integer B is equal to 128, integer C is equal to 127, integer D is equal to 127. If we do A equal B, that is typically false, right? The reason for that is because we are comparing references, right? We're not comparing the actual information that's inside of the box, right? Because these are integers, not ints. That's typically not true, right? There are some cases where this could be true if we're pointing to the same thing, right? But here, it's not correct. If you were pointing to the same thing, that's a different story. C equal D, that would typically be, actually, wait, hold on, let me see. I'd say that one's also typically false. That one's also typically false because it's two different, we're pointing at two different things. You can kind of think of it as, the only reason I'm like questioning this a bit is just because of the idea of caching. But I don't think that would apply here. So no, I think that would be false. Line line 3 is just a dot equals b. I mean, that there is true. That's literally just saying, hey, it's an integer. This is an integer. Grab me the int that's inside of them and then compare those two things, which is 128, 128. So that would be right. If it's I think a good thing to take away from this is if it's an object, equal is like the identity of it, right? So going back to that idea of aliasing, that's its name, not its value. That makes sense. Dot equals is the value, not the name. Also, don't, based off like literally me just saying about the caching thing, don't rely on caching behavior. I'm pretty sure you guys probably even really talked about it too much now that I'm thinking about it. But don't rely on caching behavior for this kind of stuff. So like the idea of you should have a 127 somewhere, that if Java's smart enough, it'll just be like, yeah, it's the same thing. Just point at the same thing. But it's more of a trap than anything else when it comes to reading this code. So don't rely on it. If I give you integer C, integer D, and they're equal to the same int, and I do C equal D, are the references the same? No, they're not. So no, that would be wrong. Typically equal, it can work for integers, but it's just not a good idea to use it because there are definitely times where it does not work. I mean, I just gave you 2. So when you're working with integers, know what you want. Basically, if you want the name of it, then we're talking about equal. If you want the value, we're talking about dot equals. Yeah, I think that one's pretty straightforward. So, yeah. So, a few rules for this. Printing an object calls its toString, right? So just like printing out the object name itself calls the toString. If you don't override their toString from object, then you get the name of your class at some hash code or some hash number. It's nonsense. But just to tell you like what that is, I don't think we'd ask you a question about that, but that's what you see when you do that. A safe equals starts with a null check and a type check, and should pair with hash code if it's necessary. So like if you're using something like a hash map or some sort of data structure or algorithm that utilizes a hash function, then it's useful to have it for sure. But for your guys' purpose, I think it's okay. Then wrapper equal compares references. Use equals with parentheses or unbox for value comparisons. Right, so the idea of compares reference or compares the name of something, right, as opposed to what's inside of the box itself, which equals would be inside of the box itself. I mean, put unbox there. If they were just int and not integer objects, would A and B be equal or true under equal? Well, two things with that. If they were all ints, if they were all ints, line 7 wouldn't compile because, that's primitives can't use methods like that. But if you were to use equal underneath for like A and B, if they were just ints, then yeah, that would work. Yeah, that would work for sure. I think probably a more interesting thing is like the idea of unboxing and boxing, that like the difference between those two. Technically speaking, if you do integer A equals some int value, right? There's a boxing thing that happens there. It has to box up 128 because that's a primitive. So it boxes that to put it with or put it inside of integer A. And then at A dot equals B, just by definition of what happens in the equals method for integer, it unboxes stuff to compare it. Yeah. So if you did int a equals, I don't know, or sorry, if you did int b equals a, right? And I just gave you those two lines, that would be both boxing and unboxing. Hopefully that makes sense. Okay, yeah. So that's the full list. Yeah, that's the full list. It's a quick run through of them. So superclass constructor calls. Superclass constructor call happens first. No args. Parent constructor means that you need to have an explicit super call that matches that argument list. If you don't, you're gonna get a compile error. This parentheses call must be the first line of a constructor. Shadowing needs this dot field. That's kind of a weird way of wording it. To avoid shadowing, you use this keyword dot whatever field it is. If you don't do that, then you run the risk of shadowing, which is the idea that at the local level, it's just reaching up to the same thing, and then you're essentially just setting it like the parameter equal to itself, and you're not updating anything at the class level. Shallow copy shares mutable internals. Deep copy breaks shared references. So shallow copy is just saying like, hey, if they're mutable, we're sharing the same thing. So if you update it, this thing's going to change for this one. This is going to change for this one. That kind of stuff. Or sorry, it's the same thing. And if you change, again, same idea with a person one, person two, they're both pointing at the same box. Or like both of them are saying that's my box, and then person one goes in, changes something, pulls something out of the box, or just switches something out. Person two is going to be like, okay, well that box has now been opened, something is switched, so now my box is switched as well. Deep copy breaks shared references, right? I mean, it just breaks off that arrow into a brand new one, right? So it's pointing at its own thing. Pass by value, mutation is visible. Parameter reassignment is not. So if you don't reassign it, then any sort of mutation you're doing to that data is seen when it's some kind of reference type, right? Overload resolution is compile time, right? And then dynamic dispatch is runtime, override only. So at compile time, it says, hey, there's 4 different methods that are overloads of one another, right? And then at compile time, Java looks and it says, okay, you just gave me you gave me a version of this method that has 4 parameters in it, right? It'll then go and say, okay, I'm going to find the method that best fits this, right? And not only that, it's going to check what the parameters are, what their types are. And if you look for the types itself and you don't see them, it's not going to let you do that. It just says no. It's ambiguous invocation. So, or if you have something like, if you have, let's say, I don't know, you call a method that takes in an int and a double, and then you have 2 methods that are, you have int double and the other one is double int, that's ambiguous invocation. That won't work. Then protected, so that's package, inside the package or inside of a subclass. That subclass can be outside of the package, can still access that information. Default is just package only. As soon as you leave the package, you cannot access that information. A private is class only, so you can only access that information inside of the class, nowhere else. Static methods, they are hidden, so they are not overridden. Reference type decides call, so what that means is at compile time, the actual reference type of whatever it is, so the stuff on the left side of the operator, your static type, that determines which method you're going to go to call. Equals needs a null check and a type safety check. So the idea of .get class. Don't use instance of, because there's problems with that when it comes to symmetry. Just use .get class. And then wrappers need equals as opposed to equal equal. Traditionally, if you're wanting to compare the insides of them, so their actual values and not just their names. Yeah. So when a value, wait, what was that? When is a value boxed? Wait, what? So when a value is boxed, is it a at definition? I mean, yeah, it doesn't have to be. I mean, there's other times that it could necessarily be boxed. It depends on what you're doing with it, right? Like if you're attempting to cast it, right, into an integer or something like that, then that's boxing it, and that's not necessarily at defining wherever it is. It's just whenever you think about it from the perspective of, okay, if I'm assigning something or if I'm working with something, right, in a way that I can only work with it when it's in this form, I need to box it up first. In the same sense that if I'm doing some sort of arithmetic with it, like if I do, I don't know, back to the idea of A and B, if I do A minus B, I have to unbox both of those, right? But then if I say C equals A minus B, that's unboxing both of those and then boxing it back up into C. Hopefully that makes sense. Nope. Okay. Okay. So I think that's about everything. Never mind. There's like a few more things. I promise I'll run through them quick. The first thing is just like debugging, because I think some people have a decent amount of people have issues with this, when it's like the difference between a compile error, a runtime error, and a logic error. So for each of these snippets, label the error as compile, runtime, or logic, and then name the fix for it. Okay, so just reading this off, string s equals null, system.out.println s.length. That one's pretty obvious, right? That's a null pointer exception because we're attempting to call something, call a method on something that is not there, right? It doesn't exist, or rather it's not defined, right? So it's null. The fix here would just be, initialize the string to something that's not null, or check for null before calling the methods. So maybe some sort of ternary operator in that print would do nicely for that. For 2, you have int array a equals the values of 1, 2, and then we have a2 equals 5. That one also I feel like pretty straightforward. We count the indexes to say, hey, this length is 2, meaning the only indexes you can actually, or the indices you can actually access are 0 and 1. 2 is not a thing that's out of bounds, right? So then that would be an array index out of bounds exception. To fix this, just change 2 to 0, the value from 0 to length minus 1. Cool. If x equals 3, and you have a bunch of stuff on the inside, that's a compile error right there, right? Oh, sorry, I don't know if I said 1 and 2 are runtime errors. 3 is a compile error, obviously, because assignments, you're doing an assignment in the condition, right? That's a pretty common error, right? Where you, instead of using equal, you use equal as it. I don't know if we do something like that sneaky on the exam, but we might. So just pay attention to that stuff. Know that there's a difference between the two, and just to look out for it. For int I equals 0, I less than or equal to r.length, I plus plus, that there is a logic error, right? It's off by 1 index. Technically, that will cause it might cause an exception. We don't know because the for loop, we don't know the body of the for loop. But that is 100% a logic error because that is, there's even a name for it. It's called off by 1. A lot of people do that. This class, I'd wager most people fall into this trap. So don't do that. Know that, if you're working with an array and you have I starting at 0, you want to go to everything except the value of length, right? Everything up until the value of length. So you just fix this by doing, I less than r.length. That's it. Okay, so then for equals in hash code, sort of the rule and the tricky piece to it, Um, if A dot equals B is true, can A dot hash code differ from B dot hash code? Well, what this is basically trying to test you on is equal is the same hash. Same hash does not mean that they're equal. Yeah, I definitely was not meant to keep that there, but it's fine. I added these really last second. But the answer to that would be no, right? If A dot equals B, so if it's equal first, right? If their equals is true, can their hash codes differ? No, they cannot. Now, if you swap that and we say, if their hash codes are equal, right? If their hash codes are equal, are they necessarily the same thing, right? Are they equal? No, they are not. That is not a guarantee. So they can differ. So equal means that if they are equal, that means that they have the same hash, which is just required. It's required by a bunch of different data structures, namely like hash map, hash set. It just is. It's used to locate equal objects in the same like bucket or patch of stuff. But then if we say that they have the same hash does not mean that they're equal. Same hash does not imply 100% that it is equal at all, because collisions exist, which you'll see more of if you go on to 1332 and such. So hopefully that makes sense. Okay, so Java docs. I feel like this isn't like huge, but I think that we definitely could ask you something about this. So, what exactly are the preconditions here, right? Well, we're saying that if I is less than 0 or I is greater than or equal to 0, and then it's saying throws index out of bounds exception, all that's saying is do this thing. That's it, right? We're saying like throw this thing if this is true. That's it, right? So in this case, we're just saying the preconditions here is that I is either equal to 0 or it's greater than 0, and it's less than size. The post condition here is just the returns piece. So returns the item at index I. Sort of an edge case here is that, the literal exception thing. So throws index out of bounds exception if I is out of range. That part don't worry too much about. It's more the preconditions and the post conditions that you should just be concerned with, and like how to actually type this out. So notice the slash star and then slash again. Like that there is a Java doc, right? If you put slash star and then slash, that's not a Java doc. I think that's it. That's pretty much it. There's not much to say about Java docs. Yeah, just be familiar. Like if you've written a Java doc before, I think you're fine. But just remind yourself of it. Okay, and then the final keyword is so the final variable cannot be reassigned, but the object it points to may still be mutable. A final method. For a final method, it cannot be overridden in the subclasses. Final class cannot be extended. So now this sort of tricky piece to it where we say final int array A equals 1, 2, and then we say A at index 0 equals 99. Will that compile? And if it does, what changes, right? So since we're saying that a final variable cannot be reassigned after initialization, right? So the referenced object here, right, is not being reassigned. And it can still be mutated, still be mutated if it is mutable. The snippet here would 100% compile, and A, 0, so at index 0, becomes 99. That's completely fine, right? However, you cannot do A equals new int array and then throwing new stuff in there. You cannot do that. That is not allowed. Also, just like an extra thing, final method final methods can't be overridden, or final classes. Wait, I already said that. Sorry. Well, I guess I'll just repeat it. Final methods cannot be overridden. Final classes can't be extended. That's it. And I think this is I want to say this is the last one, I'm pretty sure. But then like a little small thing, just like mini design prompts. So like, how exactly do you design a class? This is just an example I threw in here as something that might be good for you all to try and do. But I mean, here I think I can probably just read this off to you as like what I would do for this. But all this is really to drive home is the point of encapsulation, the point of like, when do you need to be aware of certain things? Like what variable do you need to be privy to? What methods do, or what variables do certain methods need to be allowed to access? Or what variable should be shared amongst instances, stuff like that, just like inferring things based off of the directions. So what fields do we need? Well, I mean, the fields we need would be probably a private string name, a private, probably a list, probably a private array list of like songs, and then sort of invariants would be no public instance variables, probably. Songs contain, no null or blank titles. Size matches, the number of songs. A sort of maybe almost formulating it as a kind of API. I don't think I'm going to go too much deeper into this because I think I'm starting to tread into territory you guys all need to be aware of. Yeah, I'm not going to go any deeper than that. I think that's it. Yeah, for real this time. So that's everything. I'm going to, I think I'm going to keep, I think I'm going to stop streaming and then start streaming again. And that way the VODs are different. So the first VOD will just be the review, and the second VOD will be, more just the Q&A stuff. So yeah, that's everything. Thank you everyone for showing up. Hopefully, we'll see if we do this again for exam 3. If you guys want us to do this again, just show some support for it, I guess. Maybe mention it on Ed or something. And if enough people like it, then we'll do it again. But yeah, that's everything. Happy studying. And if you want to stick around afterwards, again, I'll start the stream back up. And myself and Ron, or maybe just me at this point, because I think we went like an hour after I thought I was going to be done. We'll be on for like another hour for you to just come in. You can work on assignments, do whatever, and then just answer questions. So I'm going to go ahead and stop the stream. Thank you, everyone, again for showing up, and have a great rest of your night.